Actually, yeah. Actually, disabling the VPN is kind of cumbersome because I need to have root access to this user, which I don't want to because this is a stream user, so I'll leave it as it is. So, yeah, we can start the stream. Hello, everyone. I hope you guys have a great morning, just like me. And let me change the... How can I change the stream status? Like, let me open the chat on another window. And I want to change... How? How do you change the title? What is wrong with YouTube? Oh, here. Okay. Today we are going to do something a bit different, which will be speed running katas in Cold Wars. Let's see. And yes, this is what we are going to do. So let's start by going on Cold Wars. I probably have to log in. Yeah, 1 second. And we are now on inside Cold Wars. And the main goal is to solve as many katas as possible. So let me configure this. The chat size seems fine. Maybe I should move my camera to like, oops. Maybe I should move my camera to here, though I think it's a bit weird. But the camera, but I mean, I guess I can open a terminal and have it like the size of my camera. Let me see, please. I mean, I'm gonna make me a little bit bigger. And I think this is fine now. Yeah, I don't have two monitors. I apologize. So yeah, let's solve some katas, shall we? So yeah, let's start with this one. Let me start theme mode. Also, I kinda forgot about the music. And yeah, maybe moving the music to this step. Okay, now we can start. So yeah, let are you playing banjo? Create a function which answers the question, are you playing banjo? If your name starts with the letter R or lowercase r, you are playing the banjo. Okay. So let's... So we have the name. So we need to get the first letter. I think we can mutate the name. So we are going to create another variable and copy the character, and then if first is greater than 90, first minus equals 30, 64. It's because of the it's because of the ASCII uh, table. So if we open Python, I mean, I don't know what. Let me consult the ASCII table directly. Will be easier. So basically, okay, you see like 65, 97, and all the letters are like aligned with some constant, and that constant is basically 97 minus 65, which will get 32. So if we have like a letter and that letter is either, and we want to get like the uppercase, if it's lowercase, we just have it minus 32, and then we do a comparison, which will get the letter. I don't know why I closed this. And if the letter is 82, we are going to return name, place, banjo, else name does not play banjo. Also, there's a space here. And I think 90 is correct. Yeah, it is. Okay, so this should work. Actually, it doesn't, because it doesn't compile. I know why. Because you can do you have to do something like this. And I think it's fine. No, it's not fine. Let me result. Oh yeah. So remove the ternary. I forgot the equal sign here. And I think I also forgot to return. Why this function fails? Oh wait, I know why. This is the wrong calling convention as always with pass result. What is? It's wait, no. First is the string But I think the string needs to have... Okay, maybe the string needs to be allocated, so let's allocate a... Hmm? Oh yeah. I mean, is this... Oh. Why is this incorrect? As printf. I mean... Oh yeah, I think we need to include... No. Oh yeah, const. Oh yeah, we are trying to return a stack. So I need to malloc this. I mean 255. And it's not here, it's here. Now it works. Yeah, let's just see things. Also, we could use string copy and stircat. I mean, this is a bit clever. Oh, somewhat. I mean, I'm gonna say very because it reminded me on how cumbersome it is to work with strings in C. I mean, I really hate working with C strings. There was a test in your class and I passed it. Congratulations. But an ambitious person, you want to know if you're better than the average student in your class. You receive an array with your peers' test scores. Now calculate the average and compare your score. Return to your if you're better, else false. Okay. So we have... So basically we are going to do a for int I 0, I less than class size plus plus I, and then we are going to do then I'm gonna name this average, and then average divide itself by class size, and then I'm gonna return if your points is greater than the average. It's basically this, right? Yeah. First try. In the factory, I print labels for boxes. For one kind of boxes, the printer has to use colors which, for the sake of simplicity, are named with letters from A to M. The color used by the printer are recorded in a control string. For example, a good control string will be AAAA. This meaning that the printer used 3 times color A, 4 times color B, 1 time color H, then 1 time color A. Yeah. Okay. Sometimes doesn't have letters. Okay, this seems a bit difficult, but I think it's because it's more extensive, but I don't think it's actually that more difficult. So we're going to do a for. Actually, declare the index, and then we do while as index equals I plus plus equals no byte. So this is a post increment, so it will basically increment. It will basically increment when after the variable is read. So it's gonna be 0, and then we're gonna read this, blah blah blah. Yeah, this seems correct. So we are also going to do errors. Total. I mean, if si is less than the value of ASCII character A, which is 97, or si is greater than ASCII letter. I mean, we don't need, we actually, why am I overthinking this? We could just use the characters. Oh, I opened Speedrunning by accident. I could just type the char like this, so I also open by accident again. What the fuck? There was some Google Maps links. I leaked my address. I mean, not really. Yeah. And then we are going to do errors plus equals 1. And then we need to get gonna locate 60 bytes, and then we're going to as printf, we're going to include stdio.h. It's gonna be errors with I -1. No, I think it's just I. So, okay, this should be the entire algorithm. So we have I and errors, then we check if si is less than lowercase a, or if si is greater than lowercase m. In this case, we are going to increment errors. Then we are going to increment here, which means this could be out of bounds. I think we need to do pre-increment, but it doesn't work. Oh wait, I forgot the function signature. So, I mean, if we do pre-increment, it would basically work correctly, I think, or not. Why he printed only one? Oh yeah, I'm kinda dumb. It should be different than no byte. We are going to attempt. It will be everything correct. We are going to submit and done. Yeah. Gonna do next one. Okay, it's basically rock, paper, scissors. So we are going to make a because I think this maps to integers. I mean, it would be better to do table. So 3, 3. Table here. Going to initialize this everything by 0 and then paper, seizure. So this should be draw E2 1 E1 1. Then it should be also draw. No. Okay, so first is rock, issue paper. I need one. Rock, paper, scissors, and rock is 1, position 1, paper's position 2, and scissors position 3. So this is draw. This is just going to be B1, 1, and then just going to be B2, 1, and then just going to be B2, 1, B1, 1, and draw. I mean, and we can just return this, right? B1, B2. Right, close this bracket. Yeah, just like this. You make a table with the results outcome. It is pretty easy to do it by table. It is a very tricky trick. And I mean, the code is way cleaner than doing like a bunch of if or switch statements. So yeah. Let's see the other results. So, oh. I like it. This is actually better because it's more explicit. So if we reorder these enums, we don't break the code. Okay, I'm gonna upvote this because I really like this solution. Oh wait, gonna say it's best practice because this is code I would actually want to see in production. I mean, I would put this on a static variable because it would be, I think it generates the same instructions, to be honest. So because both are static, like they are going to be written in the progress memory anyway, the table at least. So yeah. Next one. Okay. This is, I think this is the stupidly easy. This is stupidly easy. And also convert to the correct type. Yeah, I mean, this was dumb. I don't know. I don't like this. It's too basic. I mean, it's supposed to be basic, so yeah. Can I get some can I get some difficult ones? Like, let's do rank ups. So let's get a bit more difficult. So we need to, okay, we need to convert the RGB values to strings. So yeah. This is, and we write it to the hex string it's passing to us. Okay. And this is actually 5Q. So solve this is basically converting the string values to we write this to 6 to be null terminated, and we can start with, I mean, I think we can do this by inline, because the operation is like we need to get the okay, what do we need to do here? Why is this tricky? It's because of this. So we need to get the number. So if R is less than 10, we are going to get the number by doing R divided by 10 and going to minus this with, I mean, plus this with the character 0. So if it's 0, it's going to be 0 in ASCII. If it's a number, it's going to convert it to the number. Or if it's not a number, we are still going to divide it by 10, but we are going to add 2 okay, R divided by 10. If it's if it's more than 10, we need to add it by A. Minus 10. So yeah, this is open the browser history again, trying to execute thing. Vim bindings. So yeah, I'm going to refactor this to a macro. And the lower value, we are going to just do the remainder. And yeah, just like this. So yeah, X high R X low R, and then we do the same thing for the G R 5. Then we do this to B and to B. Okay, is this correct? So to strike the high value, I don't think it's 10. It's actually 16. Because it's hexadecimal. So V, let's suppose the high, it's 255. Let's go to Python quickly. So let's suppose it's 255, which is the max value. We divide it by 60. We get basically 60. I think it's ranged to 0 to 255. Doesn't, I think integer division just claim, I mean, yeah. I mean, we just put it +1 because these are integers. Or we put +1 here, or we just do -1 here. I mean, this should work. I mean, we're just gonna do +1. So if we do 256, it's going to be 16. And if we calculate the remainder, of 60 is going to be 0. But if we calculate the remainder of 255, so this actually wouldn't work, because how could we differentiate between 0 and between the minimum and the maximum value? I mean, it would work if we just consider I mean, I think this is actually correct. No? Let's try. Oops. What happened? this seems correct. I mean, I think it's 10 here. And this is 60. Okay, almost there. Why it's at signs? Are we overshooting? Where's the at sign? Yeah, I see. Now we're going to get F. I mean, we're supposed to get F, but we're getting B. So it's minus 10. No. Expect F, but got P. Oh, it's another. So why is Oh, I see. We need to round it. So, okay, we need to do a check. Okay, so the code is actually correct. It's failing the bound. We need to do bounce check with each variable. Okay, so we need to do and then we do R G and why it's highlight. E B and we should get everything. Okay, nice. So this is very interesting. No standard libraries. I mean, I think you can do the standard library can convert it, but yeah, this should be everything correct. This is awesome. Nice solution. What the hell? We got a lot of honor. Nice. Yeah, you can do it here on the best practice here, but my solution was doesn't depend on standard library. This also depends on standard library, mine doesn't. So if you're going to see like the cleverness, oh my god, it does a table. Okay, the table one is also nice, but I like mine. Mine is clever. I mean, the table one is probably better. I don't know. It's probably better because it does encode the value on. You don't need to do these ternary conditions stuff. You can just do this calculation and use the index to get the right character. Yeah. But yeah, that's how you convert it to the cleverness. I'm gonna upvote mine. I'm giving myself a medal. I was very satisfied with this kata. It was a good one. Yeah. Okay, going to the next one. Roman numbers. Create a function that takes a Roman numeral and as its argument and returns its value as numeric decimal integer. You don't need to validate the form of the Roman numeral. Okay. So we are guaranteed that these Roman numbers are correct. So yeah. Yeah. This is a bit of an issue because I know the Roman numerals have like the other thingy. So yeah, let's do a table again. But instead of encoding the table as an array, we're going to encode as a function. And we are going to copy paste this. And then with some regex magic, we're gonna do we're gonna do this. What? Now I'm disappointed with this website. Okay, and this will be 1, 5, 10, 50, 100, 500, and 1000. And I didn't need to run the test. Let me go to the instructions again. And also, this needs to be a dot, not a comma. Okay, so we need a way I feel like this is a two-pointer solution. So let's do for I mean this is a string, so I hate this website. I hate this website. I lost my... I hate webpad. Why? Okay. Okay, so if the previous one is lesser than val, então val minus equals previous. Else we just... I mean, we can just do... I mean, we can do this because it will be out of bounds. I mean, oh yeah, it is in the pointer. And also, Okay, what is... Actually, we can just start with one, I guess. For what? Okay, we need to do an edge cage. If no, it should work still. No? Okay. Control may reach and I mean this doesn't matter. We have okay 4. This is only going to execute one time. This is oh, I see why. Okay. Okay, maybe another exception. No. I mean, it shouldn't matter because why this is okay. Val is 4. I mean, Val is 5 and I is 4 because I is less than V. 1 is less than 5. When 1 is less than 5, okay, got 2. doing this in the first place? MCD, what I got wrong? So MCD. What the hell happened? MCD. Goals. Fucking god, my neighbor with a fucking drill. Yeah. Okay, what got wrong? So 1,000. So 1,000 is less than. I mean, we should add yeah. I'm gonna mute my microphone. Okay, I think it is. Okay, so this should work, no? Because what I'm thinking about, right? What I am thinking about it. So we get the next position, and because the next position will be a null byte if we, so it's the next position will always be like a null byte, which is 0. So the next position, so if it's a null byte, it will never be greater than the value, because this is a C string. So basically is what I'm thinking is, if this value is greater than this value, we should add this value. But if this value is not greater, we should minus this value. So we add this value later, but I don't know what is happening. I don't know why it's behaving like this. Because it should be behaving correctly. I think so. MC, because M is greater than C. I think we can. Can we print the result and see? What? Huh? Okay, -1. What do you mean -1? Oh. No. The hell? I'm so confused. I'm so confused. Oh, and wait. Oh. Oh my god. I can't believe it. No. No, 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 no. That was no, 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 no. What's the fucking comma? I mean the period. No, 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 no. Oh my god. It happens. So, yeah, my mind was in the gutter. The actual error was, can I format numbers like this? No, yeah. So it doesn't need to have anything. Yeah. Okay, so this is correct. And we managed to also clean a little bit of the code, so that's nice. And also this compiles into a table. It basically has like do some calculations with, I think this switch compiles to a pointer arithmetic to calculate the right address to jump to and get the right value. So yeah, it does some clever thing that turns this into a table. So yeah. I was right. I mean, I'm satisfied. I mean, it was this, yeah, look at this. You can encode the table. You can do the table like this? but it waits some form of memory. Yeah, I don't know about it. So how many? 1.5 hours. Maybe try another one. Weird string case. Write a function that accepts a string and returns the same string with all even indexed characters in each word uppercase and all odd indexed characters in each word lowercase. The indexing just explained the zero base, so the 0th index is even, therefore the character should be uppercase. So, and you need to start over for each word. Okay. This shouldn't be hard. So basically, we do. Only alphabetical letters. Okay, so no insane edge cases. So need to allocate the... No, it duplicates. Okay, so we can mutate the string in place. So if it's odd, will be lower. If it's even, it will be upper. Yeah. This is way simpler than the other one we solved. You have ranked to 6 Q in C. Nice. Very nice. So yeah, I think this was very fun. I ranked up quite a lot. I almost doubled my rank basically. So yeah. Next rank will be 5Q. I pretend to solve more difficult ones, because the difficult ones are more fun. Like, let's solve this actually. Let me try this. The main idea is to count all the occurring characters in a string. If you have a string like ABBA, then the results will be A, B. Okay, actually simple. This is actually simple. I mean, isn't it just this? Okay, it's random memory, so it's let me do the main page. String.h, we do pass the count size, then the counts, we pass counts, the second is count size, and we pass to 0. No? Yeah. We just needed to initialize the memory. Was ridiculous. Yeah. So yeah, I mean, somewhat. I don't. Yeah, it was very easy. Was very easy. So okay, I think I'm going to practice some typing. Let's go practice some typing. Let's do code C. Although it has a lot of symbols, but we can work with it. Yeah, trying to be correct is very, very hard, and I also missed a lot. I need to go even slower. Let's try going even slower. Mm. No. Yeah, this is painful. Let me change to gold. It's way easier when you don't have symbols. So yeah, I think actually let me go to codewars again. It's very fun, but I need to take a look at the time to also launch. We can do this for another 20 minutes, I guess. So yeah, let's go. Let's do this one. The maximum sum subarray problem consists in finding the maximum sum of contiguous subsequence in an array or list of integers. Okay. Oh my god. Actually, this I don't know about it because I don't know dynamic programming. Oops. I don't know DP. I mean, if I need to study DP basically, so let me do some simpler ones. Hmm. And basically, or basically this. No. Oh, it's on reverse. It's on reverse. It's on fucking reverse. Okay, so basically we need to reverse the number. need to start higher. How can we start higher? So we need to do log. Does he have log? Yeah, it does. Let me search it. Okay, there's a log10 function. It's on math.h. So let's include math.h. So unsigned digits will be equals to seal log10 of n. This is the so if we get this right, we have 4 digits. Yes. And we are going to convert this into a 4. Do this. One. This is greater than 0. And then to extract the digit, we divide it by the digits. Again, and this blew up. Why though? Oh wait, it's times. digits, so we have 4. What do you mean? Okay. Actually, what if Okay, why it doesn't work? We don't need to do this anymore. Let's get the number, then let's square the number, and then multiply. anyone is bigger. Oh, maybe we need shift results that. Oh, it probably overflew. Yeah. But this works. But I think we can do better. Because what if we just... I mean, no. It needs to be like this, actually. Yeah. Yeah. Okay. We saw it. I mean, this is actually harder than I thought. But, yeah. Let me remove the print. Yeah. Send the test. Submit. Okay. Yeah. Okay, so I think I'm be done for today. I hope you guys like the little practice, coding practice I did. and I'll see you guys next stream. Bye bye.